What about equations that contain more than one radical? Let's consider for a moment equations that contain two radicals. The simplest equation of this kind contains two radicals with the same index and no other terms. So it either looks like the nth root of one expression equals the nth root of another expression, possibly with coefficients. We can deal with that. Or two nth roots added or subtracted together with 0 on the other side of the equation. If we have an equation that looks like this, we'll rewrite it to look like this. In general, to solve an equation of this kind, if it looks like this, we'll arrange it to look like this. So we'll arrange it so the radicals are on opposite sides of the equation. And then we can take the nth power of both sides to get rid of both radicals at once. And finally, we can finish solving. So, for example, if I have this equation, the square root of 2x plus 1 equals 3 times the square root of x plus 2. Well, it's already arranged so that the radicals are on opposite sides. We have no extra stuff added on outside either radical. So I can square both sides. Here, the square and the square root cancel. Here, the square and the square root cancel, but I also have to distribute the square onto the 3. So I'll have 2x plus 1 equals 3 squared times the square root of x plus 2 squared. 3 squared is 9, of course. I'll need to distribute. And now I need to get all the x terms on one side, all the terms without x on the other. So I'll subtract 18 on both sides, and I'll subtract 2x on both sides. I'll get negative 17 equals 7x. Divide both sides by 7. I'll get x is negative 17 sevenths. That's only the one solution, but I did square both sides. Let's see if it's extraneous. If I plug in negative 17 sevenths on the left-hand side, using a calculator for the arithmetic now, I'll get the square root of negative 27 sevenths. Oh, that's not a real number, is it? So, in fact, this one solution I got is extraneous. There are no solutions. Let me give you one of these to try. Solve this radical equation. Remember to first arrange the equation so that the radicals are on opposite sides. Pause the video and try this now. Alright, so arranging the equation so that the radicals are on opposite sides, how can we accomplish that? Well, we need to get rid of this radical, so I'll just add it to both sides. We'll get 2 times the cube root x plus 1 equals 4 times the cube root x plus 2. Now I have a single radical expression on each side. I can cube both sides. Here I have to distribute the cube in both cases. I'll get 2 cubed times x plus 1 equals 4 cubed times x plus 2. 2 cubed is 8. 4 cubed is 64. Distributing now, I get 8x plus 8 is 64x plus 64 times 2 is 128. Alright, well now I need to get all the x terms on one side, all the not x terms on the other. I'll subtract 64x on both sides, and I'll subtract 8 on both sides. Here I'll get negative 56x. And here I'll get 120. That gives me x is 120 over negative 56, which simplifies to negative 15 sevenths. Ooh, let's see if this works out. It's not going to be undefined, since this is the cube root now. I can take the cube root of something negative. So this shouldn't be an extraneous solution. I'm just checking to see if I screwed it up. So this is going to be 2 times the cube root, negative 8 sevenths, minus 4 times the cube root, negative 1 seventh. Does it equal 0? If I really wanted to, I could try to simplify these radicals, but instead, I'm just going to put these into my calculator. 2 times the cube root, negative 8 sevenths, minus 4 times the cube root, negative 1 seventh. Let's see what that gives me. Oh, that works out to 0. If I'm suspicious, 2 times the cube root, negative 8 sevenths. That works out to some horrible decimal. 4 times the cube root, negative 1 seventh. That works out to the same horrible decimal. So yes, in fact, when we subtract those, we should get 0. It works out. So x equals negative 15 sevenths is a real solution to this equation.